Nintendo Switch. Let me show you what's going on. We will not plug power to this, and you will see why in just a second. We definitely have an issue here. I don't think any bottom pin was basically spared in this catastrophe. Hopefully they did not plug power to it. No point in trying to test with the port on there because every line on the switch is probably shorted to ground or shorted to something else. So we'll remove the port and go from there. Okay, we have the board out of the housing now, and we are ready to remove the port. As I stated earlier, we must remove the port in order to do any testing. It would be pointless to do any testing at this point. So while I'm setting up my equipment, let me throw up my expected temperatures for this job. As always, these temperatures are subject to change if the job changes, but I rarely come up with these temperatures for a Nintendo Switch. And as always, these temperatures are brought to you by the Amazon Associates link in the description. If you click on any of those links and buy any of that equipment, or if you buy anything during that session after clicking on a link, a small portion of that purchase will go to supporting the channel and will be greatly appreciated. It won't cost you an extra dime. We'll switch you back to Microscope, and we're going to add some flux to our anchor points. My approach to removing a Nintendo Switch port is always to flood the anchor points with low melt. Now, as the port is not structurally broken, I feel okay with just blowing it off the board here. So that's what we're going to do. If it were structurally broken, I would probably take a little bit more care, but I'm not going to be too concerned about it at this point. It's just going to drop when it's ready to drop. The anchor is wet very quickly. And now we'll concentrate on the portion where the pins are on the other side of the board. And once they have wetted, the port should drop with the assistance of the airflow. There we go. Nice clean pull, no pull pads, and that's what we want. We do not appear to have any bridges, so we can go ahead and start our testing. And as usual, myself focused a little bit. And as usual, as typical anyway, we will start with the N92-236. We'll begin our testing. And the first capacitor we will test is the one that is connected to Pi 3 USB on the back, which is this capacitor right here. And what we want to do is follow the line to the chip. That is the side we do not want shorted to ground. It appears to be fine. And we're going to do the same routine around the chip. We're looking at the lines going to the chip. And generally speaking, those are the lines we do not want shorted to ground. Now this capacitor right here has two lines going to the chip. On a capacitor, one side will always be ground at least. There are circuits where both sides are ground. But in this case, only one side should be ground. And that's fine. This is our CPU cap. If it shows as short, that's usually a really bad sign. But it appears to be okay. And we'll move up to our MOSFET area. I always check these, though I have rarely ever run into a situation where these were short. I have run into a situation where they were short, but it wasn't the MOSFETs that shorted them. It was actually an N92-236. Okay, they seem fine. We're going to check our little filter, make sure it is fine. It is. Alright, let's check our invincible fuse and see if it's still being invincible. And it is still being invincible. Now we're going to check our test pads right here, and in this area none of these test pads should have a pathway to ground. If they do, we have a problem, and we do not. Now we're going to check our BQ24193 area, and the first thing I want to check is make sure that this coil right here is not shorted to ground. It is not. And we want to make sure it does have continuity through it. It does. Now we're going to check around our BQ24193 and make sure we have no shorts to ground where we do not want shorts to ground. The thing to note about the BQ24193 is it does have several capacitors with 2 lines going to the chip, so one side will always be grounded in that case, or at least in this circuit. Alright, everything seems to be checking out, so now we need to check out our Pi 3 USB on the back. We're reasonably certain that the Pi 3 USB is okay because it was not showing short on the N92T36 side, but we will check anyway just to confirm. On these filters, we want continuity straight through. But not side to side. And they appear to be fine. We definitely also do not want them to be shorted to ground in any way. And that is fine. Alright, now we're going to check this capacitor right here. I've never seen anything really go wrong with any other component around the Pi 3 USB. And I have tried to take resistance ratings around it, but I've gotten inconclusive results. So what we want to check is this capacitor right here. And this is the line that goes to the chip. And that's the side we do not want shorted to ground, and it appears to be fine. So at least at this point, it appears that that disastrous mess in the port did not cause additional issues. It looked like they did not apply power to the port after the mess. So that's always a good thing. And the shop did not apply power to the port. They took a look at it before trying to test it. So that was also a good thing. I get a lot of the cases where shops applied power to a port without looking in it. And doing that can have catastrophic results, can actually kill the CPU of the APU on the switch. So I advise strongly, don't ever do that. We need to begin our cleanup. As always with wick, you want to glide across the pads. You do not want to scrub. You don't want to put more pressure on the wick than is necessary to hold it on the board. Let it get to a boiling state where you see the boiling, and then glide over the pads. That's my recommendation anyway. Flux up our pads, and then we will tin them. Now using my micro pencil and Kester 446337 solder, both of which are in the description below, we will apply a solder ball on our tip, and we're just going to glide over the pads, mostly with the solder ball. You'll make some incidental contact with the tip, but really what you're trying to do is just run the solder ball over the pads. And that's how you get the nice puffy pads. Generally speaking, if you don't make any contact with the tip, you're not really stressing out the pad, you're just running solder over them. If you're having pad pulling issues, that could be your issue in this scenario. Apply a generous amount of flux onto our port. And same situation, we want to apply a ball of solder onto our tip. We're just going to run the ball over our pins here. Trying not to really make contact with the tip. Or at least as little contact as possible. This one will be cooperative. The bridge. There we go. And now we'll place our port. Freshly tinned. So what we're going to do here with my method is we're going to bring up the temperature of the board enough to wet the solder on those pads. We're going to move our nozzle rapidly so that it's never in one place long enough to burn plastic. And we will successfully solder this down. I'm going to zoom in here on the pins because I need to see when they wet. I am not fast forwarding here. This is exactly how fast I am moving the nozzle. It takes a little bit of patience, but the board will get hot enough to wet the solder on those pads. Not know where it came from. Let's get it out of there though. There we go. Okay, I think we're probably wetted. I am going to hold the port down, remove the heat, and I'm going to continue holding the port down until I see the pads dry. And I will hold it down a little bit longer even after I see the visible pads dry, because the hidden pads have quite a bit more heat retention material around them. Okay. Reasonably certain that we are soldered. I'm going to do a quick little nudge test just to be sure. If both rows are soldered down, you should get no play here when you tap the port, and I'm getting no play, so it seems like we are solid. Very good. If it was only the outer roll, you would get quite a bit of play here. It would be a little bit loosey-goosey. So seems fine. And real quick, because a solder ball popped out of there, I do want to test and make sure we have no unexpected shorting. I don't know where the solder ball came from. That's a variable. So let's just test and make sure we don't have an issue. Okay, we do not appear to have an issue. Very good. I'm also going to test this side and make sure we don't have an issue. No unexpected shorts. Alright, very good. Let's add some flux. Add some solder to our tip to facilitate our efforts. And we will feed a generous amount in. You want feed through from this side to the other side of the board. Excellent. That's precisely what you want to see on feed through. And check our pins. and they look excellent as well. Our next issue is going to be to clean off the port and clean off the board, or clean out the port and clean out the board. We'll come back when we're ready to perform a power test. Taking a look at PSU channel 1, we're looking at the amp meter, and we just want to see a certain type of behavior here. Okay, goes up and then comes back down. That looks relatively normal. We'll flip it around. And we want to get the same thing on both sides. And it looks relatively normal. Now we've grabbed our modified iPhone power squid. And for this we're going to use our OEM charger to activate. Make sure we're on channel. We are looking at channel 2, and what we're looking at is the amp meter on channel 2. And we'll just quickly plug in and then unplug. And what we want to see here is a steady current increase. And that's what we're seeing. Excellent. Okay, so it looks like it's booting fine. So this next test we're going to perform with this little apparatus. It's a brand new little thing I purchased. Hopefully we should be able to test our dock using it. We'll find out shortly. I should have hooked up my meter with it just to see. Let me hook up my meter. Why are we only getting 5 volts? Let me unplug this. Make sure we're getting 15. Okay, we are. Okay, here's our booting. We're booted. Try this again. Ah, there we go. I guess next time I will need to boot the switch first, and then we will hook up the apparatus to test with. But as you can see, it is docking, so excellent. That's a big deal because now I don't have to put the board back in the housing to test dock. Okay, we're back up and running on their battery. We're currently at about 8%. I'm going to switch this over to the PSU so you can see that it is charging on both sides. Hooking it up to the PSU. And we are fast charging on that side. Switch it around. And we're fast charging on the other side. We already know we're docking, so we don't even need to perform that test. I'm going to hook up my Joy-Cons and make sure we are charging and syncing the Joy-Cons. As you can see, we are charging the Joy-Cons. I also want to check and make sure we are getting Wi-Fi connection. And we are. I'm sorry, Bluetooth connection in this case. But we will test and see if we are getting Joy-Con. I'm sorry, Wi-Fi. And we are. So excellent. This thing is going to be kind of a game changer for me. So I will definitely put it in the description below. By the time you see this video, it'll probably have been in the description for a long while. Anyway, yeah, very good little piece of tech. I highly recommend it. If you need this type of repair performed for you, please check the description below or stick around for the end cards. And if you enjoyed this video and want to continue learning how to do it yourself, take a look at this video, and I'll see you there.